here, they bring the power right down to 24 volts for safety reasons. Okay, so it comes in and goes through your transformer. From the transformer, it goes to your contactor. Okay, on your contactor, you've got your start, S1, S2 button there. Okay, you've got your stop button, that is that there. There is your thermal overload points, okay, and there is your supply for your 24 volt, okay. Then you got your coil points, contactor coil points. You've got your D1, D1, D2, I suppose that's normally open, and D3 and D4, which is I suppose also normally open. We'll check that now, okay. So what do they ask there? What must we do?
Got the meter configured to measure resistance, the continuity, check the resistance, and therefore the state of S1 and S2. Press and hold the start button to confirm that it is either normally open or normally closed.
Okay, so we have to go to our meter,
Oh, sorry, you've got that.
put it on continuity,
Yeah.
okay. On continuity, let's just take this out. We'll use normal reads here. Okay. Confirm the various functions and parts of the contactor and associate circuitry by test. Okay. So now we have to see if that is your start button. Okay. How are we going to do that? What does the start button do?
It activates the coils to close the contactor.
The start itself. Start is that?
It
Normally
closes.
open.
Oh,
As
yeah.
soon as you push it, it closes the circuit.
Yeah, close the circuit.
And then it usually springs back.
Yeah, as soon as you leave it, okay? So if we put our meter on, what must we put our meter to test that, to test if that's your start button?
I
How
guess
we
you
gonna-
could do resistance, do a continuity test.
Continuity test, okay? Can you put that for us on,
Yeah.
if you want to test continuity?
So they're on there.
100%. So is that what we owns? Do you guys agree?
Yep, it's arms.
So we put it in here over the start button. They say that is your two start buttons. So if we press this, what we're going to see there?
We should see,
Should see.
really low resistance in theory,
Okay.
but more than zero.
Yep,
0.4.
0.4.
So if you leave it,
back to
so
zero.
that is definitely your start button. You guys agree? S1 and S2 is your start. That's no question about that. Okay. Now your start button. ST1 and ST2 is your start button.
Same thing.
Same thing?
Same thing.
You guys agree?
Yeah.
Okay. Can you put that for us onto your start button?
So there and there,
Okay.
and then press the stop
Okay.
button.
But see what your meter is doing.
It's reading 2.7 ohms,
So,
so it's
I don't-
picking up.
Already picking up. So it's already
So say
continuous.
yes, it's
So
closed.
push stop.
It should open the
Yes.
contactor, shouldn't it? So that should read 0, and it does.
Yes.
So it must be the stop.
Yep.
Must be stopped.
Yeah.
You guys agree?
Yep.
Okay. On your overload, they put a switch here
Yep.
just so that we can manually open and close the overload.
Yep.
Usually the overload is normally closed. As soon as it picks up interference, it's normally open. Okay. Can you test the overload for us? If those two buttons is the overload button?
What would be the best way to do that? I mean, because it's got a switch, you could just do a continuity test, but I imagine that's not how you do it normally.
Well, on the switch at the moment it's off. So in other words, it's supposed to be open. As soon as you put it on, it's supposed to be a close. Okay. So just test if you put it on, is that a close then? And then while it's on, you can flick your switch and check if it opens up.
Okay. And how would you normally do it if you didn't have the switch there?
If you don't have the switch, it's built into your motor, your thermal, and onto your contactor. If you've got a big contactor, They haven't got a big contactor here. Usually it is already built into your contactor on your control circuit.
So it looks like it's
It's on at the moment.
yeah, no, it's
and-
closed.
Closed.
So it must be normally off. No, normally.
So there it is. If it's an
Normally-
off position,
normally open.
then it's a closed circuit.
Yeah.
Okay. So if we're going to start building the circuit, in order, as soon as the overload trip, we will put it then on to see if it breaks the circuit. Okay. Then this is just your supply from here,
Yeah.
your 224 volts.
So just turn it around to volts.
Sorry, this comes in here. This is where your control circuit is going to start. In other words, from S1, you're going to take from 24 volts. You're going to start by your start, then go through your stop, through your thermal overload, through your contactor coil, because this is going to be 24 volts. You can't take it from there because that there is 220.
Yeah.
From there it goes through your transformer, which brings it down to 24. Okay. A1 and A2. What is that? Contactor. What? Coil. Yeah. A1 and A2 is contact. So in other words, if you put that across there, you must pick up a resistance of your coil.
Yep.
You see? So that points maybe A1 and A2. Do you guys agree?
Yep.
Okay. Then.
Is that just because of picking up magnetic flux? Or?
Yeah, it's a coil. If you check, it's kilo ohms, so it's
Oh, really low, really high.
really high. Okay, so D1 and D2. What would you say? Is that the normally open or normally closed?
Must be normally.
Normally open.
Normally open.
Yeah.
Okay, and D2 and D3.
Must be the same.
So in other words, as soon as a coil activates, then that will become a
Normally closed.
normally closed. You guys agree?
Yeah.
Okay. So, do you guys understand all the functions of all these things on this board? Any doubts?
My only question is, I understand these two and these two, but why have two lots?
Oh, you can have 3 lots. You can have 4 lots. There's no reason for not for just having one. You can just have one. But on this specific contactor, it's got 2 sets of normally opens. You know, so if you just use one, fine.
Oh, so essentially this could be running two completely separate sub-circuits.
Yes.
Yeah, I see.
So you can use this to put over your start button, and you can use this to control maybe lamps as soon as the contactor goes in.
Okay.
Yeah.
Okay. Okay, so where are we now, guys?
Experiment 2.
Okay, have you guys filled in that things? Experiment 1. Let's just go to experiment 1.
Just a little bit.
With a micro configured to measure resistance, continue to check the resistance and therefore the state of S1 and S2. So S1 and S2, it was normally open. So it was normally open.
Stop button.
And then your number 3.
The symbol would be touching.
Yes. So your symbol for a start is the one that's not touching. Okay. Then number 4. We have a meter configured to measure resistance. Check the resistance and therefore the state of S1 and S2. So S1 and S2 is that?
Yep, normally.
Sorry, S1 and S2 is that?
So that's your stop, so it'd be normally closed.
Normally plus 100%. Insert a tick next to the correct symbol to represent your choice of in the previous question. So stop button, which sign will that's a stop button? So that is your stop button, eh?
Yeah.
Okay. You can mark that one. With a meter configured to measure resistance, check the resistance and therefore the state of the overload.